Section 2.5, Compound Inequalities. Compound inequality is a vocabulary term. So let me go back to the pen here. Compound inequality, a vocabulary term. Compound inequality is an inequality formed by joining two inequalities with the word and or. Okay, we're going to start with and inequalities. And inequalities is the intersection of two different inequalities. Okay, in order for a number to be a solution, it must satisfy both inequalities. And in this section, we're going to do three different things with and or inequalities. The first thing we're going to do is we're going to graph them. Okay, so number one here, we're going to graph. We're going to have x is greater than or equal to 2 and x is less than 5. Okay, so what we're going to do, we're going to put this inequality, we're going to put these two inequalities on the same number line. Okay, so when we draw a number line with our compound inequalities, really we only need two numbers. We don't need three numbers because sometimes it might take more than three numbers to get in between or get the two numbers in our inequalities. 2 and 5 aren't that far apart. What if I made this like -12 and 31? Okay, those are very far apart. So really when you do compound inequalities, you just need two marks, the two numbers that you're going to need for your inequalities. Okay, so I'm going to focus on x is greater than or equal to 2. I know at 2 I would need a closed circle because it has an or equal to part right there. So what that means is I'm going to when I draw my arrow, since it says greater than is always that direction. Okay, and I'm going to fill this in here in just a little bit. So now I'm going to move over to the x is less than 5. So at 5 I would have an open circle because there is no or equal to part, and since it says less than, that would be to the left. Now we're looking for the numbers that are both greater than or equal to 2 and less than 5. The only way that can happen is if your solution is right in between. Okay, those are the only numbers in between them that are both bigger than 2 and smaller than 5. Okay, so when we graph our compound inequalities, specifically and inequalities, we're going to be shading in between the two circles. The question, no doubt, comes up every year is, do we need these parts, the little flags coming off the circles? The answer there is no. I'm just showing you, for visuals purpose, which way we would shade off of each circle. Let's try another one here. Number 2. We're going to have b is greater than -3 and b is less than 0. All right, so let's try another one here. Let's come up with our number line. The key with these two marked number lines is we have to make sure that the correct numbers go in the right spots. Smaller number always goes to the left. So between -3 and 0, the smaller of the two numbers definitely is, go back to the pen, -3. So then 0 would be out to the right. Okay, so if we think about b is greater than -3, that was an open circle at -3, and we would be shading that way because it's greater than. At 0, we would have an open circle again, working here now. And since it says less than, that is to the left. So obviously the numbers that are bigger than 3 and smaller than 0 are the ones in between -3 and 0. Okay, so there's our solution graph. Okay, hopefully that makes sense. That's the first task with these compound inequalities, is graphing them. And these are just the and inequalities. We'll come back to the or ones. Okay, so the next step is to translate them. We're going to actually write compound inequalities here. So number 1, a number x is greater than -8 and less than or equal to 4. There are two different ways to write a compound inequality. I'm going to write the first one where we have two separate inequalities. Okay, so a number x is greater than -8. That's pretty simple. X greater than -8. The second part, less than or equal to 4. We're going to use the same variable. We're going to have x less than or equal to 4. We should probably have the word and in between. Okay, the shortcut way, and what you're going to find in the textbook very often, and if I were you, I would get this jotted down. For an and inequality, and this only works for and inequalities, got to make that very clear. You can rewrite it in one line. You could have the small number first, followed by your less than, then your variable, then another less than, and then your big number. Okay, so small, less than x, less than big. Now obviously here we had less than or equal to, so then this would be less than or equal to as well. Okay, so just keep that in mind. Okay, so if we want to rewrite this, our small number here would be -8, so we'd have -8, and then it was less than x, and then less than or equal to our big number, which was 4. Okay, so in the textbook and on your assignment, that might be the most efficient way to write this inequality, because you do have x is greater than -8 and x is less than or equal to 4. We've written it. We've written two different inequalities, but we've written it in the same line. Okay, number 2, number c is less than 5 and greater than or equal to -2. All right, so we start, let's just jump right into the green version. Okay, so we're going to have small less than x less than or big, but we're not going to use x this time because it does tell us the right number there, c. So we're going to have c right there. Let's see, c is less than 5. This is actually the bigger number, so 5 is out here, and it says c is less than 5, so we'll have less than 5. And then it says and greater than or equal to -2. So the -2 is here, greater than or equal to -2. So we'd have to read it this way: c is greater than or equal to -2. C is greater than or equal to -2. So if it's greater than or equal to, that is this way. So -2 is less than or equal to c, which is less than 5. That would be the most efficient way to write that compound inequality. If you want to write it the more elaborate way, or the longer way, it would be c is greater than or equal to -2 and c is less than 5. 5. Okay, so that's the second task, is translating from a sentence to an inequality. The third and final task with each compound inequality is to solve and graph. Okay, the graphing we've already done, but solving is the main focus here. So let's just jump right into it. Number 1, -4 is less than x minus 2, which is less than 3. Now, we do have two inequalities here. The mistake that a lot of people make when they solve this is they split this up into two inequalities, but they split it up incorrectly. Okay? This is not how you split it up, where you go the red one and then the blue one. The red one actually extends here. It takes up all of the middle. And the blue one extends the entire middle as well. So the x minus 2, whatever is in the middle, the entire middle, belongs to both the left side and the right side. Okay, so if we're going to split this up, we'd have -4 is less than x minus 2, and x minus 2 is less than 3. X minus 2, the middle part, this part right here, that is part of both inequalities if you were to split it up. Okay, so rather than do the same step twice, so here I'd have to add 2, here I would have to add 2. Now this is a pretty simple inequality, but if we had a more elaborate one, which I'll show you in just a second, we'd be doing the same steps twice. Rather than do our work twice, we can actually do the same thing for both at the same time. Okay, so I'm going to erase those. So to get rid of the -2 in the middle, what we'd have to do is add 2. And then rather than, so if I was working with the blue one, for instance, I'd have to add 2. But if I was working with the left one, I'd have to add 2 as well. So rather than do it twice, I'm going to do it all at the same time. Okay, so -4 plus 2 on the left, that would be -2. Still have less than. The 2's cancel. I'm left with x. 3 plus 2 is 5. This right here is our answer. That's our solution. Okay, so when we go to graph, so we got the number line, -2 is smaller, so that goes out to the left, 5 on the right. Got open circles at both. This says what this inequality is stating is x is greater than -2 and less than 5. The only numbers that are greater than -2 and less than 5 are the numbers in between -2 and +5. So there's your graph for number 1. Let's try another one here. Number 2. We're going to have -3 is less than -2x plus 1 is less than or equal to 9. So this is what I was talking about earlier. Rather than split this up into two separate longer inequalities, because if we cover up this stuff over here and just look at the red one, we'd have to subtract 1, then divide by -2. If we were looking at just the blue one, we'd have to subtract 1, then divide by -2. Well, rather than do each one twice, we can do them at the same time. Okay, so the first step would be subtract 1, like I said. So subtract 1, subtract 1, subtract 1. -3 minus 1 is -4. still have less than. The 1's cancel out in the middle, so we'll have just negative 2x in the middle. And then less than or equal to 9 minus 1 is 8. Okay, so now we can keep going. Let's get rid of the negative 2 by dividing by negative 2. And remember that rule where if we multiply or divide by a negative, our inequality signs change direction. And that still holds true even in compound inequalities. Okay, so negative 4 divided by negative 2 is a positive 2. Inequality sign changes direction, still have x. Inequality sign changes direction again. 8 divided by negative 2 is negative 4. Now, this is actually written backwards, where the small number is on the right side. So if we wanted to rewrite it with negative 4 and then x and then 2, our inequality signs have to change direction and change location. So this one's going over there, that one's going that direction. And we do have to flip the sign, so less than and then less than or equal to. Okay, so if we want to graph then, 1, 2, negative 4 is smaller, positive 2 is bigger. We got a closed circle at negative 4. We have an open circle at 2. And this inequality again says x is greater than or equal to negative 4 and less than 2. The only numbers that are bigger than negative 4 and less than 2 are the numbers in between those two numbers. All right, so that's kind of an overview of and inequalities. The other type of compound inequalities is or inequalities. And or inequalities is the union or combination of two inequalities. Okay, an answer here is going to satisfy one of the inequalities, and it's not possible to satisfy both. Let me give you an example. So number one, if we're going to graph, so we're going to have y is less than or equal to negative 2, or, so now we're using the word or, y is greater than 1. If I was going to put this on a number line, so we got negative 2 out here, 1 over here. So I'm going to do the first one in red. Y is less than or equal to negative 2. So that's a closed circle at negative 2. Less than is that direction. Okay? And if I go with y is greater than 1, that's an open circle this direction. So, you know, try to think. Is there a number that is both smaller than negative 2 and bigger than 1? The answer there is no. There's not going to be a way to come up with one number that satisfies both. And that's why it's an or inequality. It's only going to work for one of the two. So what our graph is going to look like when we're done is, you know, we're going to have two bolded arrows on our number line. Okay, it's going to look a lot like this. Again, do you need these little flags? No, you don't. Every or inequality is going to look like this, where the two bolded arrows are going to be pointing away from each other. Let's try another one here. Number 2. We got a is less than negative 6, or a is greater than or equal to negative 3. All right, so let's come up with a number line here. We got negative 6 and negative 3. Negative 6 is the smaller number, so negative 6 goes to the left, negative 3 to the right. We'll do the first one in red. This is going to be an open circle, and we're going this direction. Less than is always to the left. Okay, and we bold in that arrow. We'll do the second one in blue here. A is greater than or equal to negative 3. That's a closed circle at negative 3, and greater than is always out to the right. Okay, so or inequalities always have the arrows pointing away from each other. There's no common shaded ground. There's no common ground, no common numbers that would satisfy both inequalities. Or inequalities only have numbers that satisfy one of the two. It's not possible to solve both or to satisfy both. Okay, so we graphed. Now we need to translate. A number y is at most 0 or at least 2. Now with with or inequalities, there's not a way to shorthand this. Okay, so we're just going to have to write the word or and go from there. Okay, so a number y is at most 0. So we're going to have y at most 0 means less than or equal to 0. Then we're going to need the word or, and then we got another part, at least 2. And again, we're going to use y. So we're going to have y at least 2 means greater than or equal to 2. And that's your answer right there. Y is less than or equal to 0, or y is greater than or equal to 2. Number 2, a number g is fewer than negative 6, or no less than negative 3. Okay, so we'll start with a number g is fewer than negative 6. So that's g, fewer than is less than negative 6. Going to need the word or, and then we'll do the second part, no less than negative 3. Number g, no less than means greater than or equal to, again, negative 3. Okay, or inequalities are pretty straightforward in terms of translating, because we don't have to figure out, you know, what's the smallest, what's the biggest. is it an or equal to or not. It's just basically writing two separate inequalities and putting the word or in between them. Okay, solving or inequalities is pretty straightforward as well. Okay, so number one here, we'll have 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. So obviously that the steps are going to be different from one inequality to the other. So really with this, when we've got or inequalities, all we need to do is solve each inequality individually and then graph our answer on one number line. Okay, so we'll just do the first one here in red, the left one. I'm going to add 5 to both sides. So we'll have 3y is less than negative 3. Divide both sides by 3. That means y is less than 1. Do the same thing for the second one. I'll do this one in blue. So we'll add 1 to both sides. 2y is greater than 6. Divide both sides by 2. And we got y is greater than 3. Okay, so then we can go ahead and graph the two on the same number line. 1 is smaller, 3 is bigger. We add 1, I'm going to have an open circle, and it says y is less than, so that is to the left. And don't forget to bold your arrow. And it says that for the 3, it's y is greater than 3, so that's an open circle again at 3. And greater than is out to the right. So there's your graph of your inequality. This solving or inequalities is pretty easy. It's just simple algebra rules, and we're going to have to do it twice. Okay, so let's try one more here. Number 2, we're going to have 2p plus 1 is less than negative 7, or 3 minus 2p is less than or equal to negative 1. Now what you're going to notice that your inequality signs point the same direction, so right now it doesn't really seem like it would go in opposite directions, but if you look ahead, we're probably going to be dividing by a negative number right here, so that inequality sign will change directions. So let's take care of the first one here in red. So minus 1, 2p is less than negative 8. Divide both sides by 2. That means p is less than negative 4. I divided by a positive, so my inequality sign does not change. So the second one here we'll do in blue. So I'm going to subtract 3. I don't want to add 3 here because if I added 3, 3 plus 3 is 6, and I want it to be 0. So I need to subtract 3, and if I subtract 3 on the left, I have to subtract 3 on the right. Those cancel out. I've got negative 2p because I didn't do anything with this minus sign here. Okay, and then less than or equal to negative 1 minus 3 is negative 4. Then divide both sides by negative 2. So the negative 2's cancel. P negative 4 divided by negative 2 is a positive 2. And then since I divided by a negative, this inequality sign changes direction. So instead of less than or equal to, it's now greater than or equal to. And now you can see your inequality signs point in opposite directions. So if we go ahead and graph this, we'll have negative 4 to the left because that is smaller than 2. With negative 4, I'm going to have an open circle there. It says p is less than negative 4, so less than is always out to the left. And again, make sure you bold your arrow. And then at positive 2, we're going to have a closed circle because it's got the or equal to part. So I'll have a closed circle at 2, and it says p is greater than or equal to. Greater than is always out to the right. Okay, so we will have an arrow that looks like that. Hopefully that makes sense. Kind of an overview of compound inequalities. The biggest thing, just make sure you understand if it's or and. Usually it's pretty self-explanatory. And then don't be afraid. Oops, let me go back another slide here. Try to get in the habit of using this model for and inequality. It's going to make things a lot easier, and you're going to continue to see it throughout your high school years. So try to get a little more accustomed to it.